Assalamu alaikum warahmatullahi wabarakatuh. We were discussing the solution of the homogeneous differential equation, and we use the substitution, and with the help of substitution we are able to convert that one to separable variable form. So here we're having some equations where we need the substitutions. They are not homogeneous, but we want to find the solution of this because you can see it here. This is non-homogeneous because of C. C is not having any variable. So it means when we want to find the equation, we change this one to the separable form by making substitution. We take this value is equal to u. I gave you the example last time. I just give you the same idea. Just to give the idea, I repeat that one. That was having here x plus y into dx plus 3x plus 3y. We have already solved this one in the last lecture. Into dy is equal to 0. So this was a differential equation we want to solve. Actually, this is in the form which I mentioned before. How this goes in this form, we can see it. We write in the form of dy by dx. We take this one to the other side. So get here this as 3x plus 3y minus 4 into dy is equal to minus x plus y into dx. Now we divide by dx and take to this one to the other side. We get dy by dx is equal to minus x plus y, and taking the denominator and taking 3 common, we get 3x plus y, we get here minus 4. So here I can say this is a function of xy is equal to x plus y over, we having 3x plus y minus 4. So I can write this one as function of x plus y, and I can substitute take u as x plus y. So we can see this one, that we find this one is repeating. We are having here this value x plus y. This here is repeating. This here repeating here. So we take this as equal to u, and then we can write here the value of du by dx. I explained you that one in the last lecture. So similar to this one, we are having here some other cases which I am going to discuss today, that we can have here some function relationship, and this function relationship we can have dy by dx as the function we have x plus y. We can have here the function of dy by dx. We can take dy by dx, and this is a function of y upon x, for example. So we take here this y upon x is equal to u. I would say y equal to ux. So we can have another case, number 2. We can have dy by dx is equal to a function of x upon y. So we can have here x over y is equal to u, and then here x is equal to ui. We can have the case that we having dy by dx is equal to a function of the product xy. So we get here u is equal to xy, and then we change this variable y to variable u, and we can have the transform form, and we can use that one. That the equation we are going to change, that reduce it to the separable variable, and we can solve the separable variable equation. I'm going to give you the example. Here we have the function dy by dx differential equation is y1 plus xy, x over 1 plus xy, and the condition is the x is bigger than 0. Why? Because when x becomes 0, then this become here, the denominator becomes 0, and the equation is not defined. Want to solve this equation. You can see it here that we have the function xy repeating. So this xy that become over substitution, like the case 3, we having the function of xy. When we want to solve this one, we write here y xy is equal to u. Now we want to find the value of dy by dx. We want to replace this one. So differentiate with respect to x. We get first function into derivative, second function plus second function derivative of the first function, that is equal to y. And here du by dx. We find the value of dy by dx, take y to the side. We get here x dy by dx is equal to du by dx minus y. We can get here dy by dx is equal to, we are having 1 upon x into du by dx. Now we substitute this in our differential equation, and then we reformulate that one. So I'm going to get here, when I substitute here, I get here 1 upon x into du by dx minus y, and then it's equal to, we having y is equal to, we can write the value of y. What's my y? My y is equal to u upon x. So I get here u upon x into 1 plus u, and then get here x into 1 minus u. So this here is my equal sign, and I can just multiply this by x, and this x is cancelled with x. I get here du by dx minus y is equal to u upon x, and get here 1 plus u over 1 minus u. So this is my equation I get here. Now I can just change this, my y is u upon x here. I just change that one. So I get here du by dx is equal to minus u upon x is equal to u upon x over 1 plus u into 1 minus u. So I change into the variable u and x. Now take this u upon x to the other side. I get here du by dx is equal to u upon x plus u upon x into 1 plus u or 1 minus u. I take u upon x common, and I take u upon x common, I'll get here this equal to 1 plus u over 1 minus u. Now I simplify this one. When I simplify this one, what I'll get from here, du by dx is equal to, get 1 minus u, u is cancelled with u. We get here u upon x into 2 over 1 minus u. I'll simplify further. We have du by dx is equal to 2u over x into 1 minus u. We now separate the variable. We'll get here 1 minus u over 2u is equal to dx over x, and this is my variable separable form. So this I get here. This form is my variable separable. And now here is the next stage. Next step is to integrate that one and to solve this one. So I take 1 by 2 common and divide by u. I take here 1 by 2, further simplifying it. I get here 1 over u minus 1, and here get dx over x. Now integrate that one. 1 by 2 into 1 over u minus 1 into du. Du is missing here. This is here du, and here I get here du, and this is du is equal to dx over x integrated. Take the integration. We get 1 by 2 outside. We get here ln of u, absolute value, it must be positive, minus u is equal to ln of x, and I get here plus the constant also c. I told you the constant, we can take ln of c, c square e to power c, because when you're going to differentiate, the value is going to 0. I just simplify this one, multiply by 2, I get here ln of u minus u is equal to 2 times ln of x plus 2 times ln of c. Or we can write this one as equal to ln of u minus u is equal to ln of x to power 2 plus ln of c to power 2, that's ln of x square c square. So I take, I can just put here the value of ln. I can rewrite this one, and I can write here this is equal to ln of u, and get minus, we take to other side, that become here u, and you can write here this as ln of, if I want to find ln, I can write here ln of e to power u plus ln of c square x square. I can write here this is ln of u is equal to ln of c square x square e to power u. I take the interlog of this one, I get here u is equal to ln of c square x square e to power u. I put the value of u, my u is here, xy is equal to ln is cancelled here, and we get here this equal to c square x square e to power xy, and that's the solution of my problem. So this is my general solution of the differential equation. This is my general solution, because we're having the arbitrary constant, and so we can say when the arbitrary constant is there, this is a general solution. And when we substitute the value, find the value of the arbitrary constant by using the initial conditions, then we'll get the particular solution. We substitute the value and get the particular solution. This was the example. Again, I repeat for you. This example, in this example, we are having here, this factor is repeating, and we put here this is equal to u, and then we write the value of dy by du. You can have to do this one. Then make the substitution in our differential equation. And we get a new equation, and then this new equation is reduced to the variable separable form. And after that, the thing is very easy onward, because when we having a variable separable form, we integrate both the sides. Again, regarding integration, I have already asked you many times that you need to find the technique of integrations, also the formula for the integration. If you know it, then the things are very easy. If not, then the things become difficult and take lot of time. So it's always better that you just master the technology. Number one. Number two, I want to say that the notes are available in the description. You just go there and you can go download this one. Then number three, I want to say that subscribe the channel, also make the bell icon, press the bell icon, so that you will be able to get the lectures after that one. So we are having continuously full course of differential equation. Inshallah, we're going to complete that one. And we'll get the notes and also the videos if you are going to subscribe the channel.